Australia's highly variable climate is influenced by the broad patterns in the oceans around it and the atmosphere above it. Some of these patterns are not only more obvious than others, but also predictable. We call these our climate drivers. One of our strongest climate drivers is the El Niño Southern Oscillation, or ENSO. ENSO is a natural cycle in Pacific Ocean temperatures, winds, and cloud. This influences climate right around the globe. In Australia, ENSO is often behind our climate extremes, from devastating floods to searing droughts. ENSO naturally swings between three key phases: La Niña, neutral, and El Niño. A typical ENSO phase starts in the first half of the year and lasts until the following autumn. Sometimes we can get the same phase for 2 or more years in a row. On average, it takes about 4 years to swing from El Niño to La Niña and back again. So what are these ENSO phases and how do they impact Australia's climate? Well, during the neutral phase, steady trade winds blow across the tropical Pacific from the east to west. These winds pile up warm water in the western Pacific. In contrast, water temperatures to the east are lower as the trade winds cause cool water to be drawn up from the deep. The temperature difference across the tropical Pacific Ocean causes air to rise to Australia's north and descend near South America. This creates a huge connected cycle called the Walker circulation. We consider neutral to be the normal phase because we're in this state more than half of the time. While a neutral phase may bring more normal weather to Australia, droughts and floods are certainly still possible. When we move into a La Niña, it's a bit like the neutral phase has gone into overdrive. The trade winds blow harder, expanding the warm pool on the Australian side of the tropical Pacific and cooling the oceans towards South America. This increases the east to west temperature difference and makes the Walker circulation even stronger and the trade winds blow even harder again. This is called a feedback loop, and once it starts, we're locked into a La Niña until at least the following autumn. With the higher ocean temperatures, we get greater evaporation, more cloud, and more rain in the Western Pacific. For Australia, this means a higher risk of widespread flooding, lower daytime temperatures, and more tropical cyclones. On the other end of the scale, we have El Niño, which is almost the direct opposite of La Niña. During El Niño, the trade winds actually weaken or reverse, allowing warmer waters to drift back towards the east. The change in the ocean temperature patterns mean the Walker circulation breaks down, resulting in even weaker trade winds and even more warming in the east. Once this feedback starts, El Niño has set in. With the warm water shifting east, the evaporation, cloud and rain follows, shifting away from Australia. That means a greater risk of drought for northern and eastern Australia, higher temperatures and more heat waves, clearer nights and a longer frost season, and fewer tropical cyclones. While there are scientific definitions for El Niño and La Niña, in reality, no two events and no two sets of impacts are exactly the same. We also know some impacts will emerge as an ENSO event is developing, and some will persist even if an El Niño or La Niña never fully forms. The Bureau updates the status of its ENSO tracker whenever an event may be on the horizon, so you can keep well ahead of the game. Understanding ENSO is a big part of understanding our climate, so stay up to date with our fortnightly ENSO wrap-ups and of course, watch our Climate Outlook videos.